Hello guys. So today we are going to start the first video series of our GenAI tutorials where the first tutorial will be discussing about summarization of dialogues. So it's a very basic tutorial. The intention is to get you familiar with GenAI and LLM models, and then with subsequent tutorials we'll be dealing with much more complex and good quality tutorials and examples. So if you're new to machine learning, data science, and deep learning or artificial intelligence side, you have zero knowledge or good exposure, you consider please like, share, and subscribe this YouTube channel for more hands-on tutorials in Python, R, and other tools like SageMaker, uh, Snowflake, and Databricks, blah blah stuff, right? So let's start the first tutorial of this tutorial series for GenAI, which is a summarization of dialogue. So what we're going to do, we'll have some summary conversation between let's say it's taken from some essay or some good quality notebooks or random conversations, and the task of the LLM agent is to doing a summarization. So basically it's a sequence to sequence problem, and those who does not have any idea about GenAI and all, or have very little idea, so you can quickly go through this blog. I'll give you the link of this. So this blog overall says the very basic details or the frontline information you will be requiring to follow this tutorial. So just quickly, brief introduction if I have to give, like, your Gen AI has mostly three parts. One is GAN, one is VAE, and one is transformers. So GAN and VAEs will be doing complete tutorials and application building of this as well. And today's LLM agents that we are going to use for building this application or whatever tutorials we're following is strictly on the transformer architecture. Okay, so if you see, your LLMs are nothing but your large language models. So as you have understood from the middle portion, language models means models that have the capability or first understanding of the complexity of human spoken languages. That means these models gets trained on a large, huge volume and corpus of natural language, and they have understand the context and meaning, basically, and interdependent relations between the words and basically words and what you can say, I mean, understanding the language, basically, right? And that's why the name LLM came. Okay, so quickly into our tutorial, that summarization, why it is important. So there is a lot of things have written, right, part of this document, but the very basic and most important topic is this third one, this documentation and reporting. Okay, so if you see in documentation and reporting, that's a very day-to-day job of any many IT employees. So if you can build such kind of a LLM agent by training your company's data, and you can build your own LLM, let's say agent you have built in your company's data, then the documentation and reporting part of the job becomes much more easier and very much flexible, and you requires very less human intervention and human input for this task, right? And your collaboration will become much more effective. So the first part is we require some libraries, like you can see here. We'll be requiring torch, we'll be requiring torch data, we'll be requiring transformers, and we'll be requiring datasets. So this two is coming from Hugging Face, and this two is coming from uh, your PyTorch libraries. So to save time, I have already installed all of this in this notebook. Okay, so torch data, torch you already know is nothing but your PyTorch, means your neural network library for model weights and all, and to represent as a tensor, basically. Then the second one, your torch data, is the smooth integration of the hierarchical or flat data with your torch compatibility format. Then the third one, transformer, is what we have just discussed here, right? The actual transformer. So we don't have to scratch up the code for transformers. It's already done by Hugging Face, they have provided some beautiful APIs and functions. By using those libraries and functions, basically we'll be implementing the same power with very less amount of very less line of code, basically, right? And the last one is datasets provided by Hugging Face, so that we don't have to, for doing sake of these tutorials and all, right, for understanding the concepts and tools and technologies, we don't have to rely on data collection. It's already provided here. Okay, so first part for any machine learning or data science project, as well in this LLM project as well, is loading the dataset. To load the dataset, will be requiring this datasets library. From this datasets library, will be requiring this load dataset method, right? So once that is available, then you can load the dataset. And then second part is loading your model and tokenizer. So to work along with the model, LLM models, you need to tokenize whatever text or string you want to pass. So for that, you will be requiring the tokenizers. So this line loads the model, this line loads the tokenizer. We'll be telling briefly about the next set of time. And the third step is again doing configuration or generation of parameters. So this is the third step where you will be doing the configuration of your generation parameters, like what can be the maximum length, the number of beams, the length of a penalty, whether you need early stopping or not. Okay, and this is the overall thing for this sequence to sequence job. Okay, so this 4 line of code says the required imports. I'm just running it. As you can see, we are requiring this load dataset method that we are fetching from this datasets library. From transformers library, we are fetching all the required functions for loading the model, tokenization, and configuration, right? So as we have mentioned, the first thing will be requiring the load of dataset. So we are using this dialog sum dataset that I have just opened for you guys here. So you can see this dataset has ID, dialog, summary, and topic. And the LLM agent is trying to perform the summarization of dialog, right? That means we'll be providing this dialog as input, and we'll be asking via prompt engineering our LLM agents to, okay, please do the summary, right? And a brief metadata about introduction of this dataset. You can see we have a training dataset that has 12,460 data. In validation, we have 500 data. In testing, we have 1,500 data. Okay, so this is the overall data architecture, and also you have this topic. So you can also do this dataset, utilize this dataset for topic modeling as well. Okay, so the next thing, one thing about this datasets library is that it uses Apache Arrow. So Apache Arrow is very much platform agnostic or platform independent data format that you can also read. I've also opened this Arrow. Okay, so a cross language development platform for in-memory analysis, and that's why your datasets is much more popular among the data scientists and machine learning engineers for doing all these tutorials and effective loading of data. Now, moving forward, that your dataset will be getting loaded inside this dataset object using this load dataset method, right? I'm just running it for you guys. As you can see that your dataset gets loaded. Now you can inspect the dataset. You will get all the metadata information. Okay, so your dataset has a dictionary kind of a structure that contains train, that contains test, and that contains validation, right? So now if you much more dig deeper, you can just copy paste this dataset, and I'm going to inspect what's inside this test. Okay, you can also do that. So you can see the same thing. Okay, these are the features that are available, these are the number of rows that are available. Okay, so likewise you can also see about validation and training. And as we have already seen here, right, we also have a holdout test set for with 100 rows only. Okay, now some of the examples we need to display. Okay, so Apart from example, let's say if you pass 2, what it will return. Okay, so you can see you are getting exactly whatever is there in structured, I mean dictionary format, dictionary data structure format. You have ID, you have dialogue, you have summary, and you have topic, right? So same thing you are getting. You're getting the ID, you are getting the dialogue, you are getting the summary, and you are getting the topic, right? So to access ID, what you have to pass again, you have to pass the ID, right? And you will get the ID. So like in this format, you can dig deeper about this data set. Now moving ahead, what we are getting from this code, it's a simple code to show you the example of the task. That means what will be my dialogue and what will be the baseline summary provided by human in this data set. Okay, so we are using the 40 and 200 index. You can use whatever you want, right? And nothing we are printing apart from the number of example, the dialogue, and the summary. Okay, if you run, then you will see on the first example will be your 40th index, the second example will be your 200th index, right? So in the first example, it is written as that person 1 is saying what time is it, Tom? So person 1 is referring person 2, which is which goes by the name Tom, and he is asking what is the time. Then Tom is replying that just a minute, it's 10 to 9 by my watch. Okay, so he is mentioning, okay, this is the time according to my watch. Okay, now person 1 is saying that, is it? I had no idea it was so late. I must be off now. Okay, now person 1 is raising his concern that, okay, I don't know, it became so late. Now I have to probably, you know, mean, catch a bus or catch a train or whatever. Now, person 2 is saying that, what's the hurry? Person 1 again repeating, I must catch the 9:30 train. Okay, so he has to catch a train, and that's why he is mentioning his, he is mentioning or he's expressing his emotions that he must leave by now. And as you can see here, your person 2 again saying that you have plenty of time, and confronting person 1 by saying that the railway station is very close, it won't take more than 20 minutes to get there. That means person 1 is in hurry and he wants to get off from that place quickly, and person 2 is confronting person 1 by saying that, okay, we have plenty of time, let's just wait, and we can reach the rail station by 20 minutes or so. In the second example, again there is conversation between two persons, and the input dialogues provided in a very big format, man. Okay, so okay, person one is saying, have you considered upgrading your system? That means person 1 is saying something to upgrade his system. I don't know whether it's computer or not. And again, person 2 is saying, yes, but I'm not sure what exactly I would need. Okay, so person 2 is saying that, okay, by this line a human can understand, okay, person 2 also wants to upgrade, but he does not know how to uh, upgrade like the system that he has. Probably the person 2 is like me, that I have very less understanding of this technologies and all. But anyways, this baseline human summary, as you can see here, is that person 1 teaches person 2 how to upgrade software and hardware in person 2 system, which is very much evident from these two lines only, right? That the first guy is saying that, have you considered upgrading your system, and the second guy is saying that, okay, I'm not sure exactly how I would need to do that, right? So what is the summary? That person 1 is teaching person 2 that, okay, don't be afraid, I'll teach you how to upgrade your software and hardware in your system. Okay, so that's like me who is teaching you guys like how to do this hands-on and all, right? Okay, so now we have this data. So the task is pretty much simple from a human's perspective, that you have some kind of conversation going on and you have to do a summary, right? And that's why this baseline human summaries are pretty available. But okay, can a machine do that, right? Can an NLP agent or LLM agent can do that, right, with a very less amount of code? And that's where we'll see the power of prompt engineering and the power of LLM models, right? And embedding space that it creates to understand the model language exactly like what human do. So for this purpose of example, for easy loading, we're using this T5 based sequence to sequence model provided by Google. Okay, the model has very, I mean, less amount of parameter kind of memory. So you can search more about T5 base, right? So if you just copy this one and Control C, and you can read more about this model. Okay, so you can see everything about this model. What thing I just wanted to share. Okay, okay, this research papers, right? So if you need more details, you have to go to this research paper for this T5 uh, model understanding and all, right? So that you can do on your own time for you guys. Okay, so yeah, what you can do after understanding this tutorial, you can use the same tutorial to get the summary of this research paper. That will be your task. Okay, and you can see then, okay, how good your model performing, or how good prompt engineer you are. Okay, now the next thing here, we are using this transformer for transformers API provided by Hugging Face, and from there we are using this auto model for sequence to sequence for importing the models. And once the model is import, then we have our data set available and our model available, and we'll be doing what? We'll be doing some cool stuff like summarization, right, with prompt engineering. So that's what right now we are doing. We are loading the model. So as you can see, the model is getting loaded here. So once it is loaded, first thing you have to do is tokenization. So why will be requiring tokenization? For that, you need to read this article. So if you see, we are using LLM, right? So LLM means some kind of transformer, right? And transformer goes by this attention mechanism. So if you don't know about all of this, right, please do comment so that I can give some theory videos that will help you understand all of this, right? And why RNA and LSTM fails to categorize this particular complex NLP task, which is pretty much straightforward from a human's perspective, but pretty much difficult from a machine's perspective. Okay, so this is the architecture of your LLM, sorry, transformer, and as you can see, this is the input goes to your encoder, and in here we are passing some positional encoding and input embedding space. So one embedding layer and one encoding is required in for this encoder, and then again this is the decoder architecture that we'll be discussing later point of time with some another tutorial. Let make it very much short. So as you can see, so we'll be requiring this tokenization because for this embedding space, right? Because any machine learning model understands only numbers. No, none of the machine learning model understands text or string. Okay, so that's why we are doing this tokenization. And very important point you have to remember, whenever you use any pre-trained model, always remember use the same model's tokenization method that is I mean used at the time of implementation of the model if you want to run your LLM model successfully. Okay, so this tokenizer will contains the tokenization of this I mean basically the tokenizer of this model, and if you run this tokenizer command, that means your tokenizer objects, you can see this is a T5 tokenizer, and as you have used this fast flag, that means the tokenization will use the optimized approach. Then as you can see, the model maximum length is 512, where the vocabulary size used for this tokenization is 32,100. Padding is in the right side, truncation is in right side. Okay, and these are the special characters and all you can see. Now first thing we'll be going is understanding this tokenization, how it works, and some of the functions you will be requiring. Okay, and all the examples are written here step by step. So what we are going in this statement, basically we have one sentence, we'll do tokenization or encoding basically, and we'll be returning the tensor in PyTorch tensor format. And once we'll have the encoded format or tokenized format of this sentence, what we'll be doing, we'll be doing the decoding, and we'll be requiring exactly same statement or exactly same function. That's why we'll be using this skip special token equals to true, so that if there is any special token used by this tokenizer at the time of tokenizing, it will detokenize in the same format, right? So we'll be doing this first one, and if you run this, you will see the output tensor. So this is the output tensor of this string, and this is the decoded sentence. So what you can do, you can copy this, create another code, and you can play along with. Okay, now if you change that, I am learning LLM, and it's quite fun. Okay, to run this one as well, you will see a different tensor, right? That means this is the tokenization of this sentence, and you see exactly the decoded sentence as the sentence you have provided, right? Now what you can do, you can again copy this statement. Now again you click on the code. Now you just eliminate this skip special tokens, you just make it false. Okay, I'm not going to delete, and you see what is the decoded sentence looks like. So as you can see, if you eliminate this skip special tokens, so actually how this basic tokenization method encoded this string is, I am learning LLM and it's quite a fun, then a special character, right? It's added here. So as you remember from the tokenization method, right, we are using the padding is in right side, right, and truncation also is in right side. Okay, now moving ahead, once all of this is done, that means you have understood what is tokenization, how to use tokenization, you have imported your data set and model. Now what you are going to do, you are going to perform the actual task, that means summarization of your dialogue. So first we are going to do, we are not going to use any prompt, we will be plain passing the text, that means your dialogue, and we'll be seeing what your LLM model is predicting, right? So this is the code for your prediction or output generation. So what it is doing, your tokenizer dot decode, that means it is decoding whatever tokenized tensor in PyTorch format it gets returned. And what is getting returned, your model dot generate, that model is generating some outputs basically, which is nothing but again a sequence of tokens, and then we are decoding the tokens, right? And we are also passing the tokens, as we have just discussed that any machine learning model does not understand strings, it only understands numbers, right? So again, in the printing statement, if you see, we are printing the number of example, we are printing the input prompt. That means what we are passing only dialogue, which we are referring here as prompt. We are then printing what is the baseline human summary, that means summary available along with us here. These are the summaries that are available, and we are again printing what is the model generating without any prompt engineering. That means we are passing vanilla prompts there, right? So this is the same code that's provided, that's I just have added here in the markdown section. So if you run, you can see what we have already seen, the two examples, right? We are dealing with the same set of examples. So based on whatever Tom's prompt we are getting, our baseline human summary is person one is in hurry to catch a train. Tom tells person one there is plenty of time, right? And the model is generating that, okay, person one, it's 10 to 9. This is what model is generating. It's basically a bizarre statement or absurd statement, makes no sense, right? And for example two, the baseline is person one teaches person two how to upgrade software and hardware in person two system, and you are seeing that model is generating, okay, person 1, I am thinking of upgrading my computer, which is totally wrong, by the way. Person 1 teaches person 2 how to upgrade his software and hardware, because person 1 is capable enough to upgrade his system, right? So this summarization is also wrong. So this is the very first thing that we have seen right here, without using any prompt engineering. Now it comes the prompt engineering. Now in the second part, so now right now you are familiar, right, what we have done till now in the code. We iterate over the examples, then we construct the prompts. In the previous case, we haven't constructed any prompts. We are passing plain vanilla dialogues as prompt. Now we have done tokenization, then we generate the output, then we decode the output, then we print the result. Now what we are doing, we are creating one prompt as a, if you see, it's a multi-line string, basically a raw string, right? And we're passing this instruction that, okay, summarize the following conversation, and in that we are passing the dialogue. Okay, so the dialogue is getting passed over here, and we're asking summarize that conversation. And again, same thing, the input is getting tokenized, output is getting detokenized, and we are passing the model for prediction in the output. Okay, and again we are printing the prompt, we are printing the human summary, we are printing the model generation. And this kind of prompt engineering, where we don't pass any example, we only pass the task, is called zero shot prompting. Okay, so also written here, if you see the blog, right? So here, if you see this in context learning, you will find zero shot inference, one shot inference, and few shot inference. Okay, and your zero shot inference has the affiliation with higher parameter size of model, and it is decreasing the in linear fashion the more you increase the number of examples in your prompt. You will be seeing here, right? So if you run this block of code, you will see the output here. So with no examples in prompt, only instructions, you can see your baseline summary is person 1 is in hurry to catch a train. Tom tells person 1 there is plenty of time, and the model is generating the train is about to leave. Okay, it is much more better when you give instruction to LLM agents, right? Okay, at least it is predicting, or it is trying to summarizing something that the train is about to leave. So yeah, it learned that, okay, the train is about to leave, but which is not true based on this summary, right? Because person 2 says that there is plenty of time yet, right? And the railway is nearby. But yeah, it's a sense kind of a way that the train is about to leave, right? So this is what your uh, zero prompt zero shot prompting uh, is all about. Now let's close this cell, and now let's come to again one shot. Okay, so before coming to one shot, there is another example by changing the prompt. So in the previous prompt, if you see, we have used summarize the following conversation, and here we are passing what was going on to, so we are passing the dialogue, and we are expecting not chat gpt, sorry, here it's T5 Google T5 model to answer us, okay, what is going on, or what was going on in this passage. And again we are passing the, we are printing the prompt, we are printing the summary, we are printing the zero shot generation. That means we are now changing the instruction in the prompt for the model. Okay, so if you run this one, you will see the output, and the output here is Tom is late for the train. Okay, so you see here, right, this is what it called prompt engineering. In the first phase, what you are passing, you are passing that summarize the following conversation. Now you kept everything same, and you just change the prompt. Okay, previously it was summarize the following conversation, and now it is what was going on, and you see a much improvement in your LLM output, right? So now it is predicting, or it is answering that Tom is late for the train, which is kind of true. It's not true actually, but it is kind of making more sense than the previous one, which is the train is about to leave, right? uh, so in this block, what we are doing, we are just making whatever jibber jabber code you see the Python codes, right? You have one dialogue object, you have one summary object, you are passing this dialogue in this f string to make a prompt, and then you are passing it into the tokenizer to return the input tensors, and then you are passing the input tensors into this model and whatever output provide is getting generated from the model, you are passing it to again in the tokenizer for decoding. Okay, and whatever output you get, you are just printing it, right? So the same thing, as we are going to repeat it over and over again, we're just making one function. Okay, and what we did, we just make the prompt dynamic, nothing else. Okay, so once the function is ready, so let me just rerun the cell here. The function is ready. Now what we are doing one shot prompting. That means we are passing one example, which is 40 number indices. That means which is your first example here. So we are passing this as example, and we will be expecting when we will be providing this as the task, the model will try to generate whatever output is here as similar to this one. Okay, and then we can see that okay, it actually is the machine learning. That means motion, the model learns something. Okay, and that's as we are passing one example, it is calling one shot prompt, okay, for summarization. So now this code I'm just going to run again. So this make prompt is just the function that we have just written, right? In top of this, it's nothing but a dynamic prompting query. So if you print, you can see the prompt what we are passing to the model or the agent. So this is the first example, and then again we are passing this instruction to the prompt, sorry, to the model, right? And then if you do this one, this will print you the summary. Okay, this will give you what is the baseline human summary and what is the model generation. So the baseline is again person 1 teaches person 2 how to upgrade software and hardware in person 2 system, but with one shot inference, your model is learning, I mean person 1 wants to upgrade his system, which is again wrong because person was is the teacher and he is not the student. And again person 2 wants to add a painting program to his software, which is kind of a explanation and not a summary of the statements, right? And I'm not going to the third line as it's totally not making any sense, right, with one shot. So now what we are going to do, we are going to add a few more examples. So let's say 40 indices, 80 indices, and 120 number of indices, and we are trying to print the prompt again. Close, here it is. To run this one, you will see now we are passing three examples. So this is the first example, this is the second example, this is the third example, and finally we are passing the instruction here. So we are hoping that on base of these three examples, the model will try to predict something better or try to summarize the context much better. So now if you run this setup cell, same thing, this summary statement as contains the human summary, and this output contains the output of model. Now your model is predicting, okay, token index sequences length is longer than the specified maximum sequence length. Okay, now your model is generating person 1 wants to upgrade his system, person 2 wants to add a painting program to his software, and person 1 wants to upgrade his hardware, which is completely wrong again, right? Because whatever this one and third line it is predicting or it is summarizing is the actual thing required by person 2, right? So person 1 is helping person 2 for all of this task, right? And the model is generating that no, person 1 wants to upgrade his system, person 1 wants to upgrade his hardware, which is not right, right? So this generation is also not right. And if you use LLM model or a prompt engineering like this, where your summarization has a huge deviation from the actual task, then I don't think genai or LLM will make any kind of sense to you and your company's work. Okay, so one last example that I will show here in this tutorial is, right now we have only three examples, right? So let's say we increase the number of examples, right, in the prompt. So instead of three, we are passing, let's say, 7 examples here, right? And if you can see this prompt now, we have 1 2 3 4 5 6 and 7 examples, and in the 8 we are passing the instruction that okay, I require this, and tell me a better way, or tell me like what will be the output of this, or what will be the summary, like what was going on, right? That's the instruction we are passing, because previously at the very first we have discovered that okay, if we don't say that summarize this topic, and we say what was going on, it does a better, it performs a better job, right? Now if you again run this code cell, then you see it will generate much more sensible summary of the provided input. So now it is predicting that person one recommends upgrading their system, which is kind of true, right? Person one teaches person two how to upgrade the software and hardware in person two system. So right now it is not predicting that okay, person one wants to upgrade his software or hardware, right? So it is recommending that person one is recommending someone to upgrade their system, right? Which is kind of true. So if you see, only by not changing or retraining your model, only doing a few improvement your prompt in your prompt and passing much more examples, right? That means prompt engineering, you can achieve much better accuracy in your result, right? So this is what prompt engineering, and we'll be seeing and understanding much more about this prompt engineering in the subsequent set of examples and tutorials, right? So that's it for this tutorial. Hope you liked it and enjoyed this tutorial. So if you like this tutorial, just follow us, subscribe, and follow us on YouTube and Medium, and we'll be coming to you guys again with next set of tutorials and videos of Gen AI, machine learning, and data science. Thank you very much.